All right, let's talk area. Up until now, you have relied on your old faithful formula to find area. You've been using it since middle school. It's an old, familiar friend, an oldie but goodie. When you're talking about a triangle, area of a triangle is either 1/2 times base times height, or you might say base times height divided by 2 is another way to say that. But up until now, that has been the formula that we have relied upon in order to find area. But what happens when we come to a place where that formula doesn't work anymore, either because we don't know the length of the base or we don't know the length of the height? Well, in comes our new formula for finding area, which says K, and the K really stands for area. If you figure out why K stands for area, clue me in because I would really like to know that. Area can be found by taking half the product of two sides of a triangle times the sine of their included angle. Unlike the other formula, which we had to know both a base and a height for, we could use this when we know any angle inside a triangle and the two side lengths that include that angle. So you might think about that as being the side angle side criteria, and I'm going to show you exactly what that looks like when we get a little deeper into the video. I'm going to say note that if our question involves multiple steps, there is still no rounding until the final answer. We have said in the past to show at least 4 decimals on the page, but make sure you use all decimals in your calculator. That still holds true. So that's still going to be an important thing to remember. No rounding until the end. 4 decimals on the paper, it, at least 4 decimals on the paper, and all decimals in the calculator. All right, so what is this funky new formula? Where does it come from? And why does it work? I'm going to start with any random triangle. I might try to make this a little bit of an obtuse triangle. For lack of something better, I'm going to name it ABC. I'm going to remind you that in triangle ABC, side A is represented by lowercase a and can be found across from or opposite angle A. I'm going to remind you that side C is located across from angle C, and that side B is opposite angle B. And again, in the olden days, we would have said we could find the area of this triangle by multiplying half the product of the base times the height. But where I want to go first is I want to go to this green right triangle. Because the green triangle is a right triangle, I can use my right triangle trig. And I know that in the world of right triangles, the sine value of any angle, so the sine of angle C, is equal to its opposite leg, in this case h, over its hypotenuse, in this case A. So again, all I did was a little bit of SOHCAHTOA action inside that green triangle to come up with sine of angle C equals h over A. I'm going to go ahead and cross multiply now. I'll put the sine of C over 1. And when I go ahead and cross multiply, I find that h is equal to A times the sine of C. So what I'm going to do is come back to my original area formula, and I'm going to replace that h with an A times the sine of C. I'm also going to change my A for area and make that a K for area because I'm now moving into the area formula that involves trig. So this is going to be 1/2 times B, but instead of the H, I'm going to make it A times sine of C. So K equals 1/2. I'm going to just rearrange my order here because I'm going to remind you that multiplication is a commutative operation, and it doesn't matter what order we multiply those factors in, we're still going to get the same answer. So 1/2 times A times B times sine of C. And now, folks, we have done it. We have derived or shown where that formula comes from and why it works. Okay, so where would we use such a formula? Let's go ahead and let's jump right into number 1, and we will do it. It says find the area of the given triangle to the nearest tenth. And again, I want to reiterate, our old formula is an oldie but goodie. It still works great. In this case, though, it won't work because I don't have the height of my triangle. So even though in some circumstances that old formula is going to be the way to go, this is not one of those times. But I know that one side is 7, I know that a second side is 12.6, and I know that the angle that connects them or is included between them is 33 degrees. This is a perfect scenario for my brand new formula. So this is going to be a straight up, write the formula down, k equals 1/2 times a times b times sine of c, and just go plug into my formula. My two side lengths are 7 and 12.6, so I'll make those my a and my b. My included angle, or the angle that joins those together, is 33 degrees, so at the end I'll write sine of 33 degrees. I'm going to go ahead, grab my calculator, and type all that good stuff into my calculator. So let me go open up a new document here. And I've got 1/2 times 7 times 12.6 times the sine of 33 degrees. So 24.0185. And in this question, they are asking us to round this to the nearest tenth. So rounded to the nearest tenth, my area is going to be 21.0. Make sure if it says nearest tenth, your answer includes a tenths place. And I could say square units. I could say units squared. I don't know the units in this particular problem because they weren't given to me. So I'll just say answer square units. All right, that is a classic. That is a very straightforward example of exactly how this formula should work. The important thing here is you've got two sides and the angle that connects them, or the angle that joins them. All right, moving on. Number 2 is a twist on this idea. In this case, instead of finding the area, they are telling us that the area of the triangle is 325. They're telling, or asking us, sorry, to find the measure of the angle given the lengths of two sides. So just so that I've got a good visual on what's happening in this problem, I'm going to go ahead and draw a picture. I know that the side opposite angle A is 22.5. I know that the side opposite angle B is 47. I know that we're trying to find the measure of this angle that joins those two sides. And I know that K, our area, is 325. Again, our old formula, still a great formula, but it's not going to help me achieve my objective here, which is finding the measure of angle C. My new formula, because it includes some trigonometry, is going to be much more helpful in this endeavor, finding the measure of that angle. I'm still going to start with my formula, but this time I'm going to have a K value to plug in there. I'm going to have an area to plug in. So I'm going to replace K with 325. My side lengths are 47 and 22.5. And all of that's going to be multiplied times the sine of my angle. To simplify this, I'm simply going to go into my calculator. I'm going to multiply those three factors. So I'm going to keep my 325. And the product of those three numbers was 528.75. And that's being multiplied times the sine of angle C. So I'm going to divide both sides by the 528 number in order to isolate the sine of angle C. So this is going to be 0.6146. And then a big idea here, I'm trying to find an angle measure, and in order to find an angle measure, I have to use inverse. So big idea here, use inverse to find angles. So I'm going to use inverse sine, or I'm going to take the inverse sine of both sides. And again, note that as I plug this into the calculator, there's my inverse sine. I'm using all of the digits in my calculations, even though I'm only writing 4 of them down on the paper. So angle C here is 37.9270. And they're asking us here to round to the nearest degree. So to the nearest degree, I like 38 degrees. All right, folks, there you have it. Another tool in your toolbox, another way that you could go ahead and you could find now areas of triangles. We're going to use this to find some areas of other things also when you come back to class. Thanks for hanging in, for paying attention this long. As always, I appreciate it more than I say. Hope you enjoy the rest of your day, and I will see you the next time class gets together. Take care for now.